Hello, precalc. Today we're talking about inverse trig functions, and remember in inverse functions where you switch the x's and the y's. So this time we're switching the x and the y again, but now it's your actual measurement and your angle that are going to flip. So these are very different. You will need your calculus, not your calculus, your calculator, and let's get going. All right, we're going to talk about the inverse of a sine, cosine, and tangent. We're going to use the calculator to find them and the exact values of composition functions. So when we go through here, let's just see if we can understand what an inverse is. Now it's denoted by sine to the -1. So on your calculator, above the sine, cosine, and tangent button, you have sine to the -1, cosine to the -1, and tan to the -1. Those are inverse functions. They find angles. So remember that this here is finding an angle is what it is doing. It is not switching like the opposite and the hypotenuse. All right, now the function y, the sine of x, we know -pi/2 is less than or equal to x, which is less than or equal to pi/2. All right, so this means that the inverse sine right here, I am actually finding the sine of y, which equals x. I know that sounds confusing, but we will get there. Right, so where -pi/2 is less than y is less than pi/2, so going between a -90 and a 90. X is going between -1 and 1. Right, this says y equals the inverse sine of x is how that is read. We are finding angles is what it's talking about. And we do them in between 90. So what this is saying is we're limiting our domain now. We're not going to do a full cycle. We're going to go between -pi/2 and pi/2 with me to this point. Now a sine wave isn't just a normal sine wave. We start at 0, we go up to 1. Well, if we go backwards, then we went down to -1. If you look here, we have all the values of sine in this area. It now repeats, but all the values between 1 and -1 are there. So we have every value that we need. That's why we're limiting between -pi/2 and pi/2. The inverse means we actually flip the x and the y-axis. So now the y-axis is going to be the angles. So the 1 is now pi/2, and the -1 is now -pi/2. If you look here. Now your x's, instead of your angles, become your measurements, -1 to 1. That is an inverse function. All right, so here, this is still the same. Said pi/2, 1 is now 1, pi/2. Remember, we flipped the x's and the y's. Here's the same thing. -pi/2, -1 is now -1, pi/2. Nothing earth-shattering, other than we're using pi. And we draw it, and then of course your domain and your range flip, because we have switched our x and y axis. All right, come on. My Windows just paused. Sorry about that. My Windows decided just to stop working for a little bit. Okay, here we go. Now, to find exact values of inverse functions, you're back to your unit circle. So we know we're going to rewrite theta equals sine -1 of x as sine theta equals x. All right, so we're rewriting this. The theta is going to go here, the sine goes here. Kind of like log and kind of like logs, actually. -pi/2 and pi/2, remember that gives me all the values. I don't need any more than that. And I need to find the exact values in tables to find the value of theta. So let's go here. We have theta is -pi/2, -pi/3, -pi/4, pi/6, 0, blah, blah, blah. Okay, we have all of my values of pi. All right, when we go here, the sine, well, we know the sine is -1 of pi/2, so of 90 degrees, right? -1, pi/3 is the square root of 3/2. That's your 60s, your 45s are negative square root of 2/2. Your 30 is -1/2. So these are from your unit circle. All right, again here, 30 is a positive 1/2. 45 is now a positive square root of 2/2 because now you're in the first half of your unit circle, or the first 90, and then square root of 3/2 and 1. So you're really working with your 30, 60, 90s and your 45s. Nothing unusual, just in different spots. Now, let's see what this does for us. I want to find the exact value of the inverse sine of the square root of 3 over 2. So square root of 3 over 2 is what value? And now you're thinking this is a 30, 60, 90, or is this, and hopefully into pi square root of 3, all of those. So now we go square root of 3 over 2. We know from our unit circle is pi over 3. So that means the inverse sine of the square root of 3 over 2 is pi over 3, is what that means. We're thinking backwards. What angle gives me square root of 3 over 2? And the angle is pi over 3, or your 60-degree angle. That's what you're finding is your angle. So you're using your unit circle again, just in reverse. Okay, pause and do yours. All right now you're trying to remember when the sine of theta equals a negative 1/2. Well, you know negative goes down because we're going negative pi, right here. We're negative pi over 2 to pi over 2. You don't get to go to the other side. We know that negative 1/2 is down here. And you should remember that that's a 30-degree angle, or negative pi over 6, because we went backwards around the unit circle. I hope you did well. All right, next is the cosine. It does the same thing, except now we go from 0 to pi, because 0 to pi is when I get all of my values in. I get 1 at 1 and negative 1 at pi. So between here, I will get every value that it could possibly equal. So we limit our domain from 0 to pi this time. Now we're doing our inverse. So again, the y switches to your pi, and your x switches to your 1 and negative 1. Flip your points. So now this is 1, 0. So we go to 1, 0, and we are here. Flip this point, and we are at negative 1 pi. And flip this one, we are now at 0 pi over 2. Graphing your graph. Okay, again from your unit circle, we go to cosine of theta, and we know that at 0, cosine is 1. At pi over 6, it's square root of 3 over 2. At your pi over 4, it's square root of 2 over 2. 1/3 is 1/2, 0, and then the negatives. Okay, we know that from our unit circle. So we go here, and we have the same thing with tan, but now tan is going to go from, we need to get all of our values in. I can get this here. So we're going to go negative pi over 2 to pi over 2. All right, at pi over 4 is where we get our values right here. 0, 0 is where we're going to start here. And all of our values are there. Now when we flip it, now our asymptotes are, instead of going vertically, are going to go horizontally. So horizontal, we're going to have an asymptote at pi over 2, negative pi over 2. And then again, we're going to flip our points from 1 pi over, or pi over 4 over 1 to 1 pi over 4. And the same with the negative. So nothing too crazy, right? You got to remember from our unit circle that negative pi over 3, negative pi over 4, negative pi over 6, well, that's the square root of 3, negative 1, negative square root of 3 over 3, 0, and now we have the positive version. So we have all the values that we need. All right, when you have this, this is not supposed to say that. It's supposed to say to the negative 1 power. Sorry about that. So the inverse tan of negative 1 equals theta. I'm thinking, when does the tan of theta equal negative 1? Well, I know it's negative 1 at pi over 4 when the pi over 4 is negative. So we're going down because tangent's negative in the fourth quadrant. All right, find the exact value of cosine of negative 1/2. All right, you should have said, hey, what is the cosine of theta equal in negative 1/2? Okay, you can look at your chart, or you can remember it from your unit circle, which is what you want to do for the test. And you should have come out with 2 pi over 3. Oops, can't find, there we go. So theta is equal to 2 pi over 3. All right, I hope you're doing well. Okay, now you need your calculator. Make sure you have it in front of you. We are going to put it into radian mode. So in radian mode, you want to calculate these out. So you're actually going to hit the second cosine, which gives you the inverse cosine. It's going to put a parenthesis in for you and put 1 divided by 3 and your parenthesis, and you should get 1.2310. All right, pause and do yours. All right, when you did yours, you should have said no solution here. This is outside of our range. It has to be between 1 and -1. Since it's outside of 1, -1, there's no solution. Sine will never go that high. Okay, tan will. Remember, it does not have that upper bound. So when you type that in, you got a -1.4675. 1/4 is a legal number. So you got an answer of 0.2527. Again, legal because of tan, -1.5429. I hope you did a good job. All right, next we're going to look at composite functions. And that's just when you take something inside of itself. You must realize that sine and inverse sine, the same with cosine and inverse cosine, are opposites of each other. You're going to get x for your answer because you're taking, these two are canceling themselves out, is what you're doing. The same with tan and cotan. Now let's go here. So these are fairly simple. Sine, inverse sine, those are inverses, they cancel, the answer is 0.5, whatever is inside. Cosine, cosine, cancels, answer is pi over 3. This is a number because here you were finding an angle. Now here you're taking the sine of an angle, which gives you the number. Here you're finding an angle because cosine inverse is first. So that's why you have an angle measurement. Here we go. Composite functions. There are a couple of ways to do these. We're going to show you with a triangle because I think it helps makes it clearer. And we're going to calculate the composite value. Right, I want to find the exact value of cosine tan 5/12. All right, so let's plug this in. I know that tangent of theta is equal to 5/12. I know that's opposite over adjacent. So we put 5/12 here. Now we do a squared plus b squared equals c squared, and we come up with 13. I now have all the sides of my angle, so now I can do whatever this asks. The cosine is adjacent, so it's 12/13, and I'm done. All right, oh, I forgot to go here. It said it's positive, so I know I'm in the first quadrant, because remember, negative means now it's in the fourth quadrant, because those are the only two we're dealing with. All right, come on. I'm sorry about that. My Windows froze again on me. I think it's getting tired of trig. All right, what I need you to do now is calculate this here. I would like you not to use a calculator. I would highly suggest drawing a triangle, but if you know your unit circle, you do not have to. Actually, this one you might have to because I don't think you have that value. Okay, I hope you drew your triangle out. It's negative, so now we know we're in the fourth quadrant, right? Because you can only be 1 or 4 because that's where we limited ourselves. So now when we draw this in, we drew our triangle. Our angle's here again at the origin. Okay, sine is opposite over hypotenuse, so that's -1/3. Use your Pythagorean theorem, calculate your x, and we get x is the square root of 8. Now cotangent of this angle, so we know tangent is opposite over adjacent, so cotangent is adjacent over opposite, which is just negative square root of 8. I hope you did a great job. All right, good luck on your homework. Remember to post any questions if you have any. And we're almost done. The next one's bearings. I think you're going to like it.